Cool. All right, yeah. Cool, I think we're recording. That's good to go. So yeah, once again, welcome guys. Really excited to start this semester off. And you guys got to meet some of us briefly right now, but on this slide deck, which is in the Google Drive where you'll find everything related to the curriculum, this links to a slide presentation that basically has all the members who filled them out, just more information about them, you know, like what grade they're in, what they're studying, what their interests, likes, dislikes, things like that. So yeah, please take a look at that and kind of get to know the family here, because we really do want to be a really social club, and we want this to be really fun and inclusive. And yeah, different channels there depending on what you're interested in. You guys are all in the curriculum channel, and then there's a papers club, which I will show for a minute here. Definitely join that club if you're interested in reading ML papers and discussing some of the papers. It's always a fun time. We do that on Thursdays and 5 p.m. Yeah. And so that's great way to like continue and expand your knowledge and really get down and dirty with research. It was cool. And so the G Drive, you guys will have access to that. I have like a link. So it's how the curriculum works this semester is go, you find research in the Drive, and you click over later on today we're on education, and what you're going to edit is to Google Drive and put your mic edit in there. Yeah, and so new extension to CAIS this year, which for the first time we're actually going to be uploading all of our lessons to our YouTube channel, and that's also linked here in this presentation. So you can check that out, and let's see what's going on in the chat. Where can we find the Google Drive? The Google Drive is in Slack. There's a share link, and what I can do is actually grab it right now, and I can put it in the chat. So 2020 fall curriculum, this is, and you guys can all see this, yeah. So this is the folder right here, get shareable link. I'll just copy that and paste it right here. Cool. Yeah, so hopefully now you guys all know where you can access the Google Drive. Maybe bookmark that, or keep that link somewhere easy to access. And this very presentation is in that Drive link, so you can find that to find the links to everything else that you'll need. Also, yeah, I clicked present. It was kind of laggy. There we go. Okay, so there was actually a lesson that were supposed to be done like in between the time that you guys were accepted and today, and that's lesson 0. And all that really is just a recap of the basic fundamental math that you need to know, as well as Python. So I worked on this notebook. It's really just text mostly. There's not much code or anything, but I worked on this notebook and got a lot of editing help from Zane Durante, another lead, and my predecessor as VP of Curriculum helped me a lot with that. And essentially all it is just like the absolute basic building blocks of linear algebra, of multivariable calculus, and probability theory, and some statistics stuff. And it's all the basics that you need to really understand how math behind machine learning works. So all these like key terms I've laid out here, tensor, dot product, gradient, PDF, if any of these don't sound familiar to you or you need to brush up on them, then lesson 0 is for you. So yeah, go into the G Drive, and it's just labeled 0, Intro to ML, Math, and Python. Take a look at the notebook, and the Python thing, it's pretty much just like a link to this cheat sheet, pythoncheatsheet.org. Someone else already did all the work for me, and I just like outlined the basic bullet points that would be nice for you guys to know. And another new resource that we're going to have under Zane's recommendation is office hours. So what we want to do is just have, a couple hours a week from each lead. And this is, by the way, as a message to the leads, this is optional. You're not required to do this, but it would be really nice to just kind of have like a Zoom link where you just chill out. You can just like work on your homework or whatever. And then if anybody drops in, they can ask whatever questions about literally anything. And just kind of, yeah, that's pretty much just like office hours with any professor. We just want the leads to be like available and so that you can get help from them. So that's a new addition that we're really excited about. Okay, so going into some intro stuff, and I'm sure a lot of you guys already know this, right? In fact, today's entire lesson might be a breeze for a lot of you, but you know, we're getting this started. This is our first time, so we just wanted to be really easy, really chill, have everybody on the same page. But just beginning with AI versus ML, artificial intelligence versus machine learning. What's the difference, right? Because we are AI for social good, but if we're really being technical, we really focus on machine learning, right? That's like what we're teaching, and that's our curriculum. So just a basic refresher, AI is just any sort of technique that enables a machine to be intelligent. Here it says mimic human behavior. I don't really like that. That's like kind of anthropocentric, but really it's just mimicking any sort of behavior that could be considered intelligent. And the reason that so as you can see in this Venn diagram, it's really like machine learning is a pure subset of AI. And the reason that is because machine learning is specifically those statistical methods that you use to have a machine improve over experience with data. So it's learning. Now, if you're wondering what's an example of AI that's not ML, you could come up with a really, really stupid if else statement, right? Oh, if you say this, respond this way, else respond this way. And you can just have this really intricate nested sequence of hard-coded if else statements. Technically, it would, mimic, or it would behave somewhat intelligently. So it could be considered AI, but it would not be considered machine learning because it's hard-coded. It's not learning from experience. And so that's what machine learning is. And furthermore, deep learning, which is really a lot of what we're going to be working on, is even a further subset of machine learning, which is the math behind how to make a neural network feasible. And deep really refers to this idea of having multiple layers in a neural network, which kind of increases the learning capacity. And so, yeah, once again, I'm sure a lot of you guys already know this, but that's a good recap. And yeah, another very basic idea is supervised versus unsupervised learning. And so really to sum it up really easily, supervised means you know the answer and unsupervised means you do not know the answer. So supervised learning, as you could probably guess, is way, way easier, all right? And because all you're doing is you're making a guess, comparing it to the actual right answer, which you know for sure, seeing how far away you are from the right answer, and then slowly adjusting your guessing process until you get closer and closer to the right answer. Unsupervised learning, because we don't have the right answer, is much harder, and it's much more sort of nebulous or not as easy to know how well you're doing. And so what this diagram is showing here is that, the color represents knowing. So I know a dot is either red or blue. And with that information, I know how to separate them. Whereas on the right, you don't actually know the color of the dots, but you can see these clusterings. And so, yeah, clustering and, k-nearest neighbors and these things that we'll be talking about later, those are examples of unsupervised learning algorithms. So this whole curriculum is really focused on supervised learning. We don't really go into unsupervised learning all that much. So yeah, that's all you need to know. So image classification, that's the topic for today, right? And if some of you guys have seen Silicon Valley on HBO, a great show, very funny. Their hot dog or not hot dog app, that's a perfect example of an image classification app. And the funny, the butt of the joke is everyone was super excited that they had this hot dog, this image classification app, and that it could identify something as a hot dog. But what they didn't realize is that it couldn't just identify any object. It was just a yes or no, hot dog or not hot dog. And so that's an example of a binary classification, just a yes or no. And what we're going to be doing today is much cooler. It's actually what they wish they had, which is just general image classification. Given an image, and some certain number of classes that you choose, what different types of image it can be, classified between them. So before we get into that, just a few key terms, which once again, I'm sure a lot of you guys are familiar with, but these are a lot of the key terms / jargon that you'll hear in machine learning problems. And these represent basically the different functions and ways of measuring how well you're doing. So an objective function is, simply put, as the name kind of implies, it's just what the mathematical function which you are trying to maximize or minimize. So machine learning at its core is just an optimization problem, right? You're trying to approximate some function as best as possible, and you do that by measuring how wrong you are and trying to slowly get closer and closer to the right answer. So there are numerous ways to measure how wrong you are, and we'll go over those. And there are also numerous names for them, which gets kind of confusing, but you'll hear loss function, you'll hear cost function, you'll hear error function. I think most popular by far is loss, if not cost. Loss and cost you'll hear a lot. But yeah, these all mean the same thing. It just means how wrong are you? How wrong is your average guess from the correct answer? Now, accuracy, I'm sure you guys are familiar with this concept, is just how right you are. It's like the opposite of your error. And just I put this confusion alert because this is truly kind of confusing, and it's kind of annoying that they did this. But I'm sure if you guys took some, in some science class, they probably went over accuracy versus precision. So I'm just curious if anyone wants to go ahead and try, like, what do you guys think is the difference between accuracy and precision? And this could be in terms of what you learned in like a science class or something like that. Does anybody have like a guess as to what that is? Yeah, Neil, go ahead.
Accuracy is how close it is to the correct answer, and precision is how close your answers are together to each other.
That's a concise and accurate, way to put it. Exactly. You can think of it as like a dartboard. If you get like a bunch of darts around in a circle very far from the actual bullseye, the average would be in the bullseye. So your accuracy would be high, but your precision would be very low because all the darts are really spread out. Whereas if you got all your darts close and clumped together, but not necessarily in the bullseye, your precision would be very high, but your accuracy would be low. So that's a good way to think of it. Now, this is looks like we have some chat. Is this cost? No, not exactly. So
that was a joke. I'm sorry.
Oh, is this loss? That's
yeah.
Loss, yeah.
Is this a loss? That's a funny meme. Okay, cool. All right. So yeah, loss, cost. It's like the negative. It's like the converse or the complement of accuracy. So the reason I put confusion alert here is because accuracy and precision in machine learning are actually slightly different concepts. So basically what I'm saying is like this whole accuracy versus precision thing, just kind of like forget about it, or like it's important in like science and other fields, but like in machine learning, we mean different things. So in machine learning, accuracy just means out of all your guesses, how many of them were right. That's all it means. And so precision versus recall is actually what you want to know more of, or like understand better in machine learning. And in order to understand that, you first need to understand what these acronyms stand for. So TP, TN, FP, FN, this just stands for true positive, true negative, false positive, and false negative. And you guys should be familiar with this in the context of like medical testing. Like if you have a disease and you get like a true positive. So a true positive means that they said, yes, you have the disease and you really did have the disease. True negative means they say you do not have the disease and you truly did not have the disease. False positive is saying they said you had the disease, but you didn't really. And false negative is they said that you were safe, that you were healthy, but really you had the disease. So precision and recall are ways to kind of measure how well you're doing. And precision, and I really like this. I'm actually going to just pull this up right now because I like it so much as a mnemonic of remembering. Precision and recall. So precision versus recall, you can think of precision as answering the question, how many of the selected items were relevant, versus recall is how many relevant items are selected. So yeah, this is literally just the wiki page of precision and recall. I really, really love this visualization because, so yeah, so there we go. These are the true positives, false positives. Everything in the circle is what you like, yeah, what you chose as a positive. And this, everything you chose as a positive, but some of them were actually right, and the other ones you thought were positive, but you were wrong. And then this is showing all the, like, yeah, false negatives, everything that you didn't actually pick as a positive, but they were positives. And so this is really the key right here. Precision is how many of the items that you selected, this is everything, the circle is everything you selected, how many of those were actually relevant, were actually positive. And recall is just how many relevant items, how many of the actual positives were you able to correctly recall. So a great sort of example of why this is a really important distinction is, let's say you have this disease and you know, it's only in like 0.01% of the population, super deadly disease, or like, I don't know, cancer or something. And you created this classifier. If you just, literally, you wouldn't even have to write anything. If you just wrote like guess negative, just that's it. 100% of the time it guesses negative. Well, then 99.9% of the time it would be right? Because I mean, 99.9% of the people are indeed healthy. So in that case, accuracy, or accuracy wouldn't be what you want to know. What you want to know is recall. You want to know, of the people who actually have this disease, how many was I able to correctly predict? So this is a really, really central concept and important to know, and it becomes increasingly important in class imbalanced data sets, which just means data sets where a certain class that appears a lot more than another. So in the disease example, you know, healthy people appear a lot more than people with the actual disease. And so that's a very, very class imbalanced data set. And so recall is something that you really want to pay attention to there. So that's about it. You know, hopefully all of this stuff made sense to you guys. Before we move on, are there any questions? And I'll take a look at the chat as well right now. Cool. So looks like I just did a perfect job teaching, and great. I'm the best. Awesome. So now what we can do is actually get started and start classifying some images. So this is the fun part. So what we're going to do, oh gosh, I actually didn't work out all the breakout rooms before this, but I need to do that now. What we're going to do is open up that image classification notebook and get started on actually classifying some images. So I'm going to stop sharing and stop recording as well. And slowly but surely we will